Hey guys, have your notes pulled up for section 3.2. This section is all about logarithms. That might make some of you nervous because some of you have a fear of logarithms or maybe an aversion to logarithms because maybe that didn't go so well when you were in Algebra 2, and that's understandable. In fact, none of us are really good at logarithms, so what we're going to do in this whole unit is if it's something we can just plug into our calculator, then we're going to plug it into our calculator. If it's something we have to do without a calculator, or if it involves any kind of understanding at all, we're going to switch out of logarithm mode and go into exponential mode. And I'll show you how to switch back and forth. Now, I'm not talking modes on your calculator, I'm talking modes in your brain. So we have exponential mode, and we're all fairly good at exponents. We know what exponents are, like 2 to the 4th. You know what it is. You know how to do that, even without a calculator. A log base 2, you're not so good at that. So I'll show you a way to switch into exponent mode in order to get you through what you need to do with logarithms. And it's not going to be that bad, I promise. So first of all, I kind of have the definition of logarithm written down, so you need to copy that down in your notes. It's the inverse of an exponential function. Now, I'm not going to talk about inverses a whole lot. We will when we get to graphing. I'll talk a little bit about inverses, but I'm not going to dwell on the fact that they're inverses, okay? What I am going to dwell on is when you're confused about a logarithm, what do you do with it? So, you need to have this written down in your notes. Maybe you need to pause the video and copy it before I start explaining what all this is, and you're going to have to memorize it. So, I basically said all this. We're not good at logarithms, so we're going to be switching back and forth between logs and exponents, and I'm going to show you how to do that. So the first switch that we have going on is, let's say that you have a logarithm. And so here's what a logarithm means. We read log base b of x equals y. That's how you say it. Log base b of x equals y. So we're not sure what to do with this. We don't know what logarithms mean. When we have numbers in here, we're like, I don't know what that means. Okay, so here's what I want you to do with it. First of all, I know you all are more comfortable with y equals form, but for the sake of logarithms and exponents, would you please write them in equals y form? So have your log or your exponent, whatever, over here on the left, and have your y on the right. A little unconventional, a little bit not what you're used to, but it makes the whole switching back and forth technique way easier if you'll write it like that. So here's what I'm going to have you do. We're going to switch out of logarithm mode, and we're going to turn it into an exponent. So you're going to start with your base. You're going to always start with your base. Oh, golly. Here we go. I'm going to start with my base. My base is b, so I'm going to say b. And I'm going to swirl around. So I start with the base, I swirl around the equation, I grab the y, and I end at the x. Start with the base, swirl around, grab the y, end at the x. Ready? Here's how it goes. B to the y power equals x. Start with the base. Remember, we're changing it to an exponent. So since this says log of, when I switch it to an exponent, I've got to say something to the power. So I'm going to grab the base. Start here. B to the power of y equals x. And I write it just like this. This is something you all understand. When you have numbers in here, you get this. Okay? So start with the base. We're going to change it to exponent mode. So you're going to say this, whatever this base is, to the whatever this is, equals whatever this is. And occasionally, not very often, but occasionally I might need you to switch it back to a logarithm. So let's say that we're currently in exponent mode. In our brain, we know that this to this power gives us this answer. change it to a logarithm. And you're like, well, why would I want to do that? Logarithms are hard. Just because I asked you to. Let's just go with that for now. Just change it to a logarithm so you'll get the feel of the back and the forth with switching it around. So, again, you're going to start with the base. The base is here, right? Base, exponent. You all know your vocabulary. We're switching it to a logarithm. So the first thing you need to do is write log. I'm switching this to a logarithm. So the first thing I do is I write log. Ready? Here's what follows. Log base b of x equals y. So I start with the base, I swirl around, I grab that, and I end here. You know your logarithm has to go log base b of something equals this. So you write log, this is the base. This is what we're taking the log of, and this is your answer to your logarithm. Log base b of x is equal to y. So that's how you're going to switch from back and forth. Remember, put it in equals y notation on your paper, a little unconventional. Start with the base, swirl around. Start with the base, swirl around. Okay? Now, in your previous video in 3.1, I showed you what the graph of an exponential function looks like, and I asked you to memorize it. So, today, I'm going to show you what the graph of a logarithm function looks like, and I'm going to ask you to memorize it, just like I did over there. So, let's say you've got a logarithm, and it's set up like this. I don't care what your base is. Your base can be 2, your base can be 10, your base can be 100. Doesn't matter. This is what your logarithm function looks like. It's never going to touch the y-axis. It's going to cross the x-axis at the point 1, 0. That's important. Memorize that. And then it's not going to level off. It's going to keep going right and up forever. And here are a couple of examples of just a typical logarithm function whose graph looks like that. Log base 2 of x equals y. Log base 7 of x equals y. Yeah, this graph might be a little bit steeper than this one, but not much. They pretty much all look the same. So, take out your highlighter. You need to memorize some things. Memorize what the function looks like. Memorize what the graph looks like. And memorize that important point. Pretty much the 3 things that I had you memorize for an exponential function. The function, the equation, the graph, and the important point. All right, let's do some of these examples together. So, first thing it says is, hey, let's take a current true logarithm and change it to the different form. So, notice I've clearly stated, hey, these are in logarithm form. We are going to change them to exponential form. Here I go. Changing it, I'm going to grab the base, swirl around, hit the 3, end at the 125. So I'm going to write an exponential function. I'm not going to write log anymore. I'm going to go base 5 to the power of 3 equals 125. 5 to the power of 3 equals 125. True statement. 5 times 5 is 25, times another 5 is 125. Sure. Next one. Grab the base, swirl around, pass through the 6, end at 64. Changing it to exponential, I've got 2 to the 6th power equals 64. Does it really? 2, 4, 8, 16 times 2, 32, 64. Yep, 2 to the 6 equals 64. Okay? This makes sense to you. This doesn't, and that's okay. It's all right. Every time you see something like this, switch modes in your brain and think of it like this. All right, and just for fun, to get you used to switching back and forth, we are currently in exponent mode in our brain on our paper. Let's switch to logarithm mode. Let's change these to logarithms. First thing I'm going to do, I'm going to write L-O-G, L-O-G. Since we're switching to logarithm mode, I'll go ahead and get that part out of the way. Now, I know in my logarithm equation, I have to have log, I have to have a base, I have to have what I'm taking the log of, and I have to have equals my answer. So I'm going to go to my exponential. I'm going to start with the base, swirl around, end at the 3. So this is going to be log base 6 of 216 equals the answer, which is 3. See? Started here. This was my base. This comes next in my problem, what we're taking the log of, and this is my final answer. Next one, base. Swirl around. So I've got log base 3 of 1/9 equals -2. These should make sense to you. These, probably not so much, and that's okay. Okay, the next part that I've got highlighted in pink, you're going to have to memorize these two things. Common logs and natural logs allow you to write less on your paper, and most of you think that's a good thing. Like, really, do I have to write all this out? No, you really don't. So whenever you're taking a log and your base is 10, if and only if your base is 10, it's called the common log. And whenever you write those out, you don't have to put the 10 down there. Kind of like, y'all know when you square root something, we don't put the little 2 on our little root symbol. But we do put the 3 on if we're cube rooting. We do put the 4 on if we're fourth rooting. But 2, the square root is so common, we don't have to write the 2. So that's how this is. This is so common, you don't have to write the 10. And then there's the natural log, and this is when you have log base e. Now remember, e is just like 2.7-ish, not a big deal. It's just a symbol for an irrational number. So when your base is e, you, instead of writing log, you can just write ln. ln stands for the natural log. Different from common log. It's the natural log. So when you see this, you know your base is e. When you see this, you know your base is 10. And you need to memorize those. Let's practice a little bit with common logs and natural logs. So it says translate. So currently I'm recognizing, hey, these are in logarithm notation. Let's transfer them, change modes to exponent notation. So I don't have to write it, but I want to write it so you'll recognize, oh yeah, that was the common log. So since there was nothing here, we know automatically our base is 10. So to change it to exponent, start with the base, swirl around, end at the 1000. I write 10 to the third power equals 1000. Next one, logarithm. This is the natural log. So really this is log base e. I'm going to put this down here. This is not good notation, but I just want you to be able to see a base, see where we're starting. So I put the base in, start here, circle it around, and I write e to the 1.0986 equals 3. Weird, I know. You're like, ooh, that's a weird exponent. Yes, it is, but that's the way it's set up. This to the equals. Next two. There's currently an exponent notation. Let's change modes to logarithm notation. So the first thing I'm going to do, I'm going to log, right? If I'm writing logs, let me go ahead and get the log out of the way. Start with the base, swirl around. So I go log base 10 of 0.01 equals, and I end with my final answer of -2. Oh, now wait a minute. If that's log base 10, I really don't even need to write the 10. How about this? So this is a good answer. This is a good answer. Either way. Next one. Start with the base, swirl around. Log base e of 5.5527 equals final answer. Now, here's where I really prefer you to write this as a natural log. There we go. I mean, this is okay. This is the way to write it. All right, now I'm going to go through these properties of logarithms. They look intimidating just because there's a lot of them, and it's like, okay, I'm going to ask you to memorize them, but hold on a minute before you panic. Before you panic, make a note to yourself, this one-to-one property is going to be important. You might want to pause the video, go find a Post-it note and put a Post-it note in your notes. You're going to be asked to use it later. Let me focus on that for a minute. The one-to-one property. I call it the common sense property. Ready? This logarithm and this logarithm are equal. So, on my left and my right sides, they both say log. They both have a base b. Now, in order for these two things to be equal, if this and this and this and this are the same, wouldn't it make sense that these have to be the same? That's what the one-to-one property says, aka the common sense property. If everything in your equation looks exactly the same and they're equal, well then this has got to be the same as this. One-to-one property, common sense property. Next thing I'll point out, and you don't have to memorize this yet, this is more like a calculus thing where you really need to know a lot about logarithms, but let me just throw this out. The common log and the natural log, actually all logs, but whatever, are only defined when what you're taking the log of is positive. You can only do a logarithm if what you're taking the log of is positive. Why is that? You can only do a logarithm if what you're taking the log of is positive. Why is that? Watch. Ready? 2 to what power could give me an answer of a negative? Let me say it one more time. 2 to the power of what could result in a negative answer? Nothing. This will never be negative. 7 to the power of what gives me a nothing? See, I'm explaining logarithms and I'm using exponents. 2 to the power of, right? Because we don't get logarithms, we get exponents. So in order to tell you, hey, whatever you're taking the log of can never be negative, I'm explaining that using exponents. Why can this not be negative? Because 2 to whatever power is not going to give me a negative answer here. Okay, anyway, moving on. Ready? Let me go over these. Pencils down, just watch. I'm going to ask you to memorize them. You're going to be like, oh my gosh. No. They're not bad. They're not bad at all. I promise. Ready? Your base is 10, right? 10 to the 0 is 1. 10 to the 0 power is 1. Y'all knew that. E to the 0 power is 1. Y'all knew that. Oh, here's one. Hey, let's pretend we don't know the answer. Ready? Pretend we don't know the answer. Any number to what power is 1? 0. Y'all know this. Next row. You ready? Common log. 10 to the first equals 10. You knew that. Next one, base E. E to the first equals E. Oh my gosh, y'all knew that. Oh, what about this one? Let's pretend we don't know this answer. Pretend we don't know this answer. Ready? Any number to what power equals itself? The answer is 1. See, I told you they weren't hard. Okay, now this one's just funny. Ready? Base is 10, common log. 10 to the k equals, that's funny. Next one, ready? Base E. E to the k equals, of course it does. Let's pretend we don't know the answer. Ready? Pretend we don't know this answer. Ready? B to the what equals B to the k? Oh my gosh. Obviously, that has to be k. Okay, now these last ones are kind of hard, but you're gonna get the hang of it and you're gonna find a shortcut. So, I know y'all are all about shortcuts. So let me explain how this works. Did you know that 10 to the common log of v is just v? You probably didn't know that. And e to the natural log of v is just v. So pretty much anything to the log of, as long as it has that base, is just v. Okay, let me show you how this works. Currently, all of those are 10 to the, e to the, b to the. They're currently in exponent form. I've identified there. I know there's a logarithm there, but when you go to say it, it's an exponent form, 10 to the. So it's currently in exponent form. Let's change that to logarithm. You're like, why would you do that? Just hang on a minute. Let's just change it to a logarithm. Pretend we don't know this. Pretend we don't know what that is. In fact, I'll call it question mark. Ready? Change it to logarithm mode. So I'm going to go, I start log regardless. Changing it to logarithm mode. Ready? Grab the base. Swirl around. So I'm going to write log base 10 of question mark equals log of v. See what I did? Changing it to logarithm, I went ahead and wrote log, and then I took the base, swirled around. So log base 10. This comes next. This whole exponent is my answer. Now, look closely. Do y'all have common sense or not? Oh, wait, maybe you don't see it. What? If there's nothing written there, what goes there? There you go, common sense property. They're equal. I got the L, I got the O, I got the G, I got the 10. What would the question mark have to be? It would have to be V. So my answer is V. Now, do you see how there's like a pattern? As long as this base on your logarithm matches the base on your exponent, your answer is just that. As long as the base of your logarithm matches the base of your overall exponent, your power here. This is a base, then your answer is just that. See, bases match, answer is just V. You might have to refer back to these for this last one for a while. I don't think you're going to be real quick in knowing those answers. Okay. Here we go. We're going to evaluate some logarithms together. And you can take your equation and set it equal to a variable if you want. I just put it equal to question mark because right now we don't know the answer to these. So ready? It's time for you to evaluate 5 logarithms. How good are you at logarithms? You're not. So let's change them all to exponents. Ready? Here we go. So I'm going to write on my paper, 3 to the what equals 81? Figure it out. 3 times 3 is 9, times 3 is 27, times 3 is, oh, 4th. My answer is 4. Next one, you're not good at logarithms. Change it to an exponent. 2 to the what equals, oh, I don't think you're going to be good at that. How about this? I change this to 1/4. Well, this is 2 squared. Oh, hang on, I wrote that wrong. Sorry. 2 to the question mark is 1/4. Well, this is 2 squared, but it's in the denominator, so my answer would have to be -2. My exponent would have to be negative. Next one. Y'all aren't good at logarithms. Change it to an exponent. 5 to the what equals 1? Oh, everybody knows that. Next one. 3 to the what equals the 7th root of 3? Okay, well, I'm about to show you something that I need you to all understand and memorize. When you have roots, they are the same as fractional exponents. And I kind of went over this yesterday with the flower power. But this is a root. So it'd be a fractional exponent and it goes on the bottom. So this is an exponent of 1/7. A 7th root is an exponent of 1/7. A 6th root is 1/6 exponent. A 5th root, 1/5. Square root, 1/2 is your exponent. So that's 1/7. Question mark would have to be 1/7. And the last one, base, swirl around, 9 to the what power is 3? Well, this one's kind of tough because you got 9, and then if you square it, you got 81. We are clearly going in the wrong direction. We need to shrink it. So we actually know that if we square root 9, we get 3. Since the square root of 9 is 3, then I think that 9 to the 1/2 power is 3. So our answer is 1/2. All right, you will be asked to do things like this on a test without a calculator. So basically, know how to show that one step, changing it to exponent form before giving me your final answer. All right, we're almost there. Last one. We've got this, looks like a complicated logarithm equation. So something kind of confusing, equals -1 times the log of this. And it goes on to say, what things represent and all that, but I've kind of highlighted it for you. So this is kind of like y equals -1 times log of something, like x. So I colored this kind of orangey, and I colored this kind of greenish. It's saying, part A says, find this when you sub in this here. Okay, so hopefully you can see that that number gets subbed into my log, and what I get out of it is my answer. So I did that, typed it in my calculator, and I used the LOG button, and I get approximately 3.5229. Next one. Find the green if you plug in the orange. So 3.5 equals negative LOG of that weird thing. That's the weird thing that I'm trying to solve for. And I plugged in 3.5. Okay, a couple things. One is, remember how I said, I know you all prefer y equals, but it's kind of unconventional, so flip it around. Okay, well, that's still there. That's still there. All right. One thing before I tell you what to do, we need this to be just a logarithm, not a -1 times a logarithm. So I need you to divide both sides by -1. Right? How good are you all at logarithms? You're not. So let's change this. Let's get it out of logarithm mode, and I can do that because I got rid of the negative in front of it. Let's get this out of logarithm mode and into exponent mode. So start with your base. You know it's 10. Start with the base and swirl around. Watch what I write. I write 10 to the 3.5 equals, sorry, that's a negative. 10 to this, -3.5, equals, final answer, type it in your calculator. Type in 10 to the -3.5. And you should get 3 zeros, 316. All right, that's all. Good luck.